You know, some projects are so complex, so ambitious, that failure just isn't an option. Today, we're going to break down the spiral model, a really powerful framework that was designed for exactly those high-stakes situations. Let's dive in. So let's just kick things off with a pretty huge question. When you're building software for something like aerospace or a massive financial system, or really any project where the unknowns just totally outweigh the knowns, a simple plan isn't going to cut it. You know those traditional linear approaches? The ones where you plan absolutely everything up front and then just execute? Well, they tend to fall apart under this kind of pressure. They make this massive assumption that you know everything from day one, which, let's be honest, is almost never the case for truly innovative projects. And that brings us to the core problem, right? Rigid models, like the classic waterfall approach, they're fine for predictable, well-understood projects, but they become brittle, even dangerous when you're facing a ton of uncertainty and risk. So, seeing this exact problem, a computer scientist named Barry Boehm realized that for the biggest, most ambitious projects out there, we needed a model that actually embraced uncertainty instead of just ignoring it and hoping for the best. And what he came up with was the spiral model. It's a complete shift in thinking. We're moving away from a straight line to this expanding loop that puts one thing above all else: managing risk. So what is it exactly? Well, you can think of it like a hybrid model. It takes the structured planning from traditional methods and mixes it with the flexibility of building in small iterative cycles. But the real game changer is that constant, almost obsessive focus on risk. And that first part, a risk-driven process model, that's the phrase that changes everything. In other models, risk is often this afterthought, like a footnote in the project plan. But in the spiral model, risk is the engine. Every single decision, every loop, every line of code is driven by the question, what's our biggest risk right now, and how do we crush it? The best way to picture this isn't a straight road, but, well, a spiral. With each loop, the project grows. It might start as just a simple concept or a really rough prototype, but with every single cycle, it gets more refined, more robust, and more complete. Okay, so how does this whole thing actually work in practice? Well, every single loop of that spiral is broken down into 4 distinct steps, or quadrants. First up, you plan. In this quadrant, the team figures out the goals for this specific iteration. What are we trying to accomplish in this loop? What are our limitations? What do we need to get it done? It really just sets the stage for everything else. Second, and honestly, this is the model's secret sauce: risk analysis. This is where the team just brainstorms everything that could possibly go wrong. Technical hurdles, budget problems, shifting requirements, you name it. Then they actually build small prototypes or run experiments just to tackle the biggest uncertainties head on. And the placement of this step is critical. By putting risk analysis before any major engineering work, the model forces a constant reality check. It's like a built-in safety mechanism that stops teams from pouring time and money into building something that was doomed from the start. Third, we have engineering. Okay, once the big risks for this cycle have been dealt with, the team finally gets to work. This is where the coding, the building, the testing happens. They build the next version of the product using all the lessons they just learned. And finally, evaluation. The customer, the end user, gets their hands on what was just built. And they give feedback, which is absolutely crucial. That feedback becomes a main input for the planning phase of the very next loop of the spiral. And so the cycle starts all over again, but this time, you're on much more solid ground. So this powerful cyclical approach is incredibly effective, but it's not a silver bullet. It comes with a very specific set of pros and cons that you really need to understand. So on the plus side, its ability to manage risk is, well, it's unparalleled. It's just perfectly suited for those large, messy projects where you know things are going to change. And that constant customer feedback loop makes sure you're always building the right thing. It's incredibly flexible. But, and this is a big but, all that power comes at a cost. All that detailed planning and prototyping and risk analysis makes it very, very expensive. It's total overkill for small, simple projects. Plus, you need a really skilled team to manage all that complexity, which makes it super tough to guess the final cost and timeline from the outset. So, what's the bottom line here? It's all about knowing when to pull this highly specialized tool out of the toolbox. It's not for every job, but for the right job, it can be an absolute lifesaver. And honestly, nothing makes this clearer than putting it right next to the traditional waterfall model. Look at this. Where waterfall is linear and rigid, spiral is iterative and flexible. Where waterfall has pretty much no formal place for risk, for spiral, it's the absolute core of the whole process. They're just designed for completely different kinds of problems. So when do you actually use it? The signs are pretty clear. If your project is huge with a big budget, if you're playing with brand new, untested tech, if the risk of failure is massive, and if you need constant check-ins with your customer, then the spiral model should be at the very top of your list. Yeah, we are not talking about building a simple website here. We're talking about the kind of systems that power space exploration or global finance or groundbreaking artificial intelligence. These are the arenas where the spiral model really truly shines. So, if we boil all this down, what's the big takeaway? The core idea of the spiral model is that building complex software isn't like following a blueprint on an assembly line. It's much more like exploring uncharted territory. You need a map for sure, but you also have to be ready to adapt to whatever you find along the way.
It basically admits, hey, we don't have all the answers at the beginning, and that's okay. It builds in those safety nets, the risk analysis, the prototypes, the customer feedback, to let teams navigate all that uncertainty safely and actually succeed at building the technology of tomorrow.
And that leaves us with one last question to chew on. As our ambitions get bigger and our technology gets exponentially more complex, are we reaching a point where these principles of risk-driven development aren't just for NASA anymore, but maybe a necessity for any major project? It's definitely something to think about.